Archives of Prasar Bharati presents the timeless treasure of golden era.
Dr. Narlekar is the head of the Inter-University Center for Astronomy and Astrophysics at Pune. He is regarded by many as India's Einstein, a global authority on the origins of the universe, its evolution, and dare I say, its destiny. Dr. Narlekar has held distinguished chairs at the universities of Cambridge and several North American universities. He's been honored with the Padma Bhushan. Professor Narlekar, you're well known for the Hoyle-Narlekar theory. Could you tell us simply, briefly, what is the Hoyle-Narlekar theory?
We started work on this in the 60s and we're still working on it. The idea is that when we talk of inertia of matter, that is when you want to push some matter around and it doesn't move, you have to apply force, we say it has got inertia. The question is, how did that inertia come into the matter? Now, there was a theory proposed by Mach, the philosopher, scientist of last century, that inertia comes because of the presence of the matter in a well-filled universe. If the universe were empty, matter will not have any inertia. That was his idea. But it was a philosophical thought. And Einstein thought that it could be incorporated in his theory of relativity. But later on it turned out that it is not included in relativity. So Fred Hoyle and I, when we were looking at it, we approached from a different angle, started with Mach's idea, gave a mathematical form, and then we discovered to our surprise that in a certain limit, and not in the general case, you get relativity theory. So it sort of produced a cohesion of ideas of Mach and Einstein. Today we are linking it with the overall structure of the universe and how it evolves, as you said, how it started. We find that it never started. It has all the time been in existence.
You know, much of popular science writing today has been concerned with the origins of the universe, and we hear a great deal of the Big Bang theory. And of course, much of your early work and your interest has been in debunking the Big Bang theory. How did the universe really begin? What would you say to a layperson?
Yeah. Well, there is a very simple way of looking at these ideas, and there is, of course, a complicated mathematical way. So I will take the
simple way.
Simple way. Now, if you said the universe started in a big explosion, then you can ask how long ago did that explosion take place. Now, this can be calculated, and you can work out what is the age of the universe up to the present epoch. Now, it turns out, according to the most popular theory of the Big Bang, that the age is about 8 billion years. Now, you say 8 billion is a long time, but astronomers have been reporting that there are certain stars and galaxies which are older than this. Recently, about a few months back, Hubble Space Telescope reported the findings of how fast the universe is expanding, and that gave a conflict that the stars are older than the universe. So the idea that the universe started in a Big Bang seems to be under some trouble. Instead, if you say that the universe had never had a beginning, but all the time it has been there and new matter keeps coming in and gets expanded out of our horizon, then there is no conflict with the astronomical observations.
You know, in purely layperson's terms, when we don't think too deeply about it and someone says beginning of the universe, you tend to think that that's when it all began. You know, when you look up at the stars at night, you see the night and things like that. And obviously, sort of the human brain, the human mind, the layperson's mind certainly, so struggles to fathom what happened before the beginning of the universe, if there was a beginning. You know, what explanation, reassurance, how do you begin to comprehend something of that magnitude?
I think at some stage you find that your intuition is inadequate to understand these issues, and then you resort to mathematics and the ideas of physics. So your question about the extent of the universe, when it started, it gives you problem about beginning, that is what was there before. Now there are mathematical ideas which tell you that there is no such thing as before. The whole time axis, or the clock started ticking from the origin of the universe. So the idea of before, whether in philosophical sense or intellectual sense or perception, it does not make any meaning. You have to say that at t equal to 0, universe came into existence, my clock started ticking, and we start measuring time only from that instant. Now this is a possible way of explaining things, but then you run into problems about how matter came into existence, why whatever we see around us came into existence at that particular moment. And sometimes you throw up your hands and say this is beyond science.
Would you then take sort of the Buddhist view and say, look, we can't figure out exactly how and why not just the universe, but matter began, and so let's not think about it?
No, I don't throw up my hands and say that. My attitude is more, let us try and expand the idea. It is inadequate in its present form when you say the universe started at a particular instant. Rather, if you say the universe had no beginning and no end, then it's easier to work with, and let us push our scientific ideas as far as they go. If we again run into some kind of a brick wall, we have to revise these concepts also.
You know, we hear a lot again in popular science writing about the black hole. You have evolved an idea of the white hole. Again, in layperson's terms, what is the white hole?
Well, the idea of a black hole is something which is black, that you cannot see it. Why don't you see it? Because its strong gravity pulls everything inwards. A white hole is the reverse of it. It's very bright, and you see things coming out from that. So the idea of a white hole is essentially a source of energy and matter. And you find, when you look at the universe, you find there are quasars, which are tremendous sources of energy. Quasars are, the word quasar is a short for quasi-stellar object. So something which is like a star, quasi-stellar, but it's not exactly a star. In fact, a quasar is much more powerful than an ordinary star like the sun, maybe a billion or even 1,000 billion times as powerful as the sun. So the question is, what's happening in a quasar? So you find tremendous amount of matter and energy pouring outwards in the form of jets or in the form of radiation. Now this, I would say, is a manifestation of a white hole where things are coming out, rather than a black hole where things are going in. So the notion of a white hole is related to what I would call mini creation events, that is, matter being created in small isolated events. So mini bangs instead of one big bang. When the whole universe was created, you now talk of mini bangs.
You talk about the creation of the universe. You know, as a science student in school and sort of with a very superficial knowledge of science, you know, you're aware of the Newtonian world, where everything is sort of deterministic and it's predictable. And now you have chaos theory, order in chaos. Is it fair to say that you have moved away from the deterministic theory of the universe?
I
is it
think
possible to predict?
Scientists in general have moved away from the completely deterministic attitude, partly because when quantum theory came into existence as a new theory of micro world, it became very clear that you cannot predict how a microsystem, like inside of an atom or an electron going around a nucleus, how they would behave according to the purely deterministic laws of mechanics which Newton had given us. So a new mechanics, the quantum mechanics, came up, which was based on probabilistic statements that I cannot definitely say what will happen, but there is a certain chance it will go this way or that way. So then later on chaos came. Chaos theories are not quantum mechanics, not exactly Newtonian mechanics, but they tell you that some systems behave in such a way that even if you start writing their equations, the equations don't tell you exactly what will happen. You have a wide range of possibilities, because you make slight change in your local initial starting conditions, you find a vast difference in the outcome. So all these ideas, although they looked to start with very strange or out of touch with reality, the reality itself has changed so much that we find that all these ideas are needed to understand different aspects of the universe.
You know, there's a popular book, Order Out of Chaos. What is this order in chaos? How would you explain this to someone who hadn't even studied science in school?
Well, you can have chaos in the sense that you cannot predict what each subsystem of a thing is going to do.
And what do we mean by systems here?
Well, let us take, to give you a small example, you have a series of subatomic particles, you know, like electrons, protons, neutrons, and you have a group of them and you create them somewhere, produce them and hurl them at each other. Now when they collide, what will happen? You know, what is the outcome? The thing is, you cannot precisely say what will happen. You have a notion that if this is the initial statement, this is the final outcome. But since you don't know the initial conditions so well, you have to fold all those possibilities into a mathematical theory, and then you say this is the outcome. Now, if you take some ideas of the universe or some ideas of how certain subsystems of this universe behaved, you have the origin in a complex situation where you cannot say what will happen to the individual component. But maybe something happened afterwards, like expansion of the universe. When the universe expands, and this is one of the observations that people believe in, everybody believes in, then because of the expansion, the chaotic situation sort of cools down, it gets smoothed out, and things become more predictable. So you can use your good old Newtonian ideas, what we call classical physics, to understand the large-scale structure of the universe. So you can produce what we think is an order out of something which was unpredictable. So there are many such examples which come into physics.
At some risk, to borrow a phrase more from, I think, religion and philosophy, what then is the destiny, as it were, of the universe? Where are we headed?
Again, it would depend on your mathematical model as to what you think the universe is like at present, or
But
how
beyond
it was.
mathematics, can you sort of suggest this to us in terms of
So-
ideas that we may be able to comprehend?
So let us look at the present state. It shows the universe is expanding, and there are galaxies moving away from each other, you know, at tremendous speeds. So you ask, what is it going to lead to all this? So one alternative that we have in front today, in front of us, is that the whole universe will expand, keep on expanding, and all galaxies will move away from each other, so that they are no longer visible to one another. So if we are just now able to see a lot of galaxies, maybe after 10,000 billion years later, our successors, if they train their telescopes, they won't find any galaxy. The universe will be dark.
We will look up at the sky and we won't see any stars.
No, the stars inside the galaxies might exist, you know, but another galaxy like our own, which normally to naked eye are not visible, but through telescopes you can see them. They will have moved away. But look at the stars also. Stars take some time to burn out completely. So if there are no new stars forming, after about 10 or 50 billion years, all stars that we see shining today will have sort of burnt out and will be either black holes or very faint stars. So the sky that we will look at will be completely almost dark. So it is not a very pleasant prospect. The other alternative is that the expansion goes on, then it stops and it contracts. Now that aspect can be equally unpleasant or frightening, in the sense that if the galaxies are moving further out, and if they start coming in, they will come closer and closer until you have what is called a big crunch. Everything will be...
Which is the reverse of the Big Bang.
Big Bang. The third alternative is what we call our version of quasi-steady state cosmology, where you have the universe expanding, but there are cycles of expansion and contraction. But they don't go to exactly a big crunch or they start with a big bang, but they are sort of more mild versions of this phenomenon, that galaxies come closer but not crush each other. They come closer, then they move apart, but don't go away to infinity. So we still have our neighbors. Then they come close again. So this goes on and on.
You know, beyond the realms of academic exploration and theorizing, what implication do these sort of insights have on human consciousness, on human beings and our interaction with each other, in our perceptions of ourselves, in our pursuit of happiness?
Well, I can only speak for myself. I first of all feel awed by the immensity of the universe. So it immediately puts me in my place, that I may have some ego, that I have a certain role or certain place, but I immediately realize that it is such a small location at the earth itself and the human population, that when you are trying to grapple with these problems, our understanding is very inadequate. So it tends to instill into you, whether successfully or not, I don't know, but a sense of modesty, that the problems are very enormous, and we cannot make or even hope to make a complete, cannot achieve a complete solution to these problems. But they also pose challenges, that there are mysteries and you want to solve them. So if you take the old religions, they always were guided by mysteries, that is, who made this universe? If you go to the Upanishads, there are a number of questions which are put.
Do you find, you know, at one time there was it was very popular in the West, and you had people like Fritjof Capra and things who were doing the power physics, and a lot of books of that genre came out. Yeah. Have you delved into them, and do you find that there was a legitimacy in trying to find this meeting ground, or was it?
I have looked at them, read some of them, and so on, but I myself am not convinced that this is the right way to go. Certainly there were questions being asked by people in the past, our ancestors, and they had certain ideas which do find similarity in terms of what modern quantum mechanics or modern cosmology says. But if you examine carefully, these similarities, in my opinion, are superficial. In particular, we don't have any mathematical or quantitative statement coming from the older ideas. They are more philosophical. So I would not like to say that we have exactly been reproducing what the old people, civilizations had said. But it's always interesting to see that at certain level, the ideas which guided those people are coming back to us.
You have written extensively promoting the scientific temper, the scientific method, and the scientific sensibility. I remember a recent article debunking astrology. Well, first tell us, what for you is a scientific temper?
Scientific temper is something which goes beyond science. It started as a method of science. What happens in science is that you have certain ideas, hypotheses, which are used to make predictions about how the cosmos is, how the cosmos will behave. And if the predictions are borne out by experiment or by observation, then only those ideas will propagate. Other ideas which are thrown out because they don't agree with observations are they die a natural death. So there is a spirit of questioning all the time, and that spirit of questioning should be present even in our daily actions. We should be asking, why am I doing this? What is the rationale behind it? So a rationalistic attitude should be there. Now, if somebody tells me that that at the time of the solar eclipse I must have a bath or I must not come out of the house, I should not simply accept that. This person may tell me, if you come out, something evil will fall on you. So the irrational thing is, why take a chance? Let me be inside. The sun is going to be eclipsed only for a few minutes. And many people adopt this and stay indoors and miss a very fantastic astronomical event. Instead, one should ask, what is going to be the harm in coming out? You discover that there is no harm in coming out. The problem arises in some cases if you are rash enough to look at the sun thinking it is covered, so there is no danger looking at it. What happens is there are ultraviolet rays which are still coming out from the outside of the periphery of the sun, and they harm your eyes. So if you take proper precautions, look through filtered glasses, there is no problem. But people have converted this into some kind of a hoodoo.
How would science explain love and compassion and altruism and poetry and music?
Science, in fact, does not claim to understand everything, and certainly those aspects which are related to human emotions or human thoughts or even consciousness, which you mentioned earlier, human consciousness, these have remained so far, in my opinion, outside the realm of science. Whether they will ever come into scientific investigation, I do not know. Now biologists are talking about the study of the brain, how the human brain or any brain operates. So I'm sure the next few breakthroughs will be about neurology and how the basic information is propagated from the brain to the body and so on. But even if you have solved that problem, whether these emotional aspects will be automatically covered, I'm doubtful.
Where would you say are the limits of science in the capacity of the human mind, of the human brain to know itself? And it's, I think, as human consciousness or the human mind, even sort of the biochemical matter that is the brain, has struggled to know itself. And when it has failed, it has yielded to philosophy and metaphysics and the mysteries of religion and philosophy. Are you uncomfortable with that?
I think where the interest into these other fields, non-scientific fields, has come because of a negative inspiration, that you have not understood something, therefore you go to those fields. I think there is a weakness in the approach. But I don't see any reason why. I mean, if I enjoy a certain piece of classical music, even though I don't understand why I enjoy it, it doesn't stop me from enjoying it. And I don't think those aspects of human brain or human side, which involve enjoyment of the aesthetic aspect, although they are not scientifically explained, it doesn't mean that they have no existence or they are inferior in any way. In fact, they pose challenges to science to expand its territory, which at the moment doesn't extend to them, to try to find a rationale behind it.
Do you seek pleasures and diversions outside science, and if so, what are they?
Well, one of my pleasures is also in the form of reading and writing, and I like to read humorous literature, and I've been a fan of P.G. Wodehouse.
You've had a long and productive and rewarding and eminent career as a cosmologist. What is your remaining aspiration, as it were? Is there something that you want to crack, define, identify, pin, achieve?
Well, rather than look back and see what I have achieved, I rather like to look ahead and see what are the interesting problems to be solved. And I think there is that storehouse which
is there one that dominates and obsesses you, that when you're having a shower you think, well, if I could get this?
Well, I have this nagging feeling that nagging feeling that what people normally believe as the origin of the universe, the Big Bang cosmology, has got to be wrong, and there must be some observational evidence like the one I mentioned about the ages. More such evidence is bound to come out to prove this. So I'm hoping that in the years left for me, I will be able to find both theoretical and observational evidence which tells us that the universe is much more complicated than what the Big Bang people assume.
You know, you mentioned briefly the destiny of the universe, and we talked about that. Do you see a destiny for the human species on the planet?
Well, there is the short-term question of whether we become so complex that we destroy ourselves. This is a very likely possibility which we have to be aware of, that as our scientific progress advances, we have more capacity of self-destruction, either in a dramatic fashion through a nuclear warfare or in a slow but steady fashion by polluting the Earth's atmosphere. So both possibilities exist. The second possibility is probably more dangerous because we don't realize it. It's a slow poisoning, as it were. So I feel that if we are able to get wise to all these dangers, then there is there's certainly a great destiny, and one would expect that maybe next century we may have contact with some other civilization somewhere. Our technology is growing at a rate where we might be able to receive radio signals from other more advanced civilizations.
And if you were able to establish contact and communicate to them, what would you say?
What will I say? Well, it's not so easy, because if they are several light years away, whatever I say today, something which, some question I may ask them, it will reach them, say, if they are 10 light years away, that will reach them 10 years from now. And then we reply, if they reply, the answer will reach 20 years from the time I asked the question. So it's not very easy to carry conversation.
Is there a cosmic equivalent of a hello on the telephone?
Not cosmic equivalent of a hello, but there is, people believe, a cosmic equivalent of a wavelength which people can use for propagation, and that is the 21 centimeter wavelength of neutral hydrogen, which is common all over the galaxy. So any other extraterrestrial will be aware of it, although he will not use centimeter as a unit and call it 21 centimeter, but the actual length will be the same. So if we are tuning our receivers to receive signals, there is a good chance if we put it on 21 centimeter waveband, we might get some intelligent signals. What they say will not be, of course, very easy to decipher. But if they are sending some scientific information, I think we can decipher it.
Professor Narlikar, thank you very much.